In this video, we look at a very common algebra question where you're supposed to determine the domain of a function where you're given the function's equation, not its graph, not a mapping or set of ordered pairs or a table or chart or something, but from an equation, a formula. So let's get some basics down here. What is domain? Domain is the inputs, the set of inputs. And that's really what most people remember, okay? It's a set of inputs. But specifically, it's a set of inputs that don't cause any calculation problems, okay? And if you want to know more precisely what that means is that output real numbers. So if you have a calculation that does not output a real number, then the number you input would not be in the domain. What are these calculations that we're talking about? Well, there are two calculations that cause problems, that don't output real numbers. The first one is dividing by zero. It doesn't even output a number, right? It's undefined. You can't divide by zero in any case. The second one is taking a square root of a negative number. You can take a square root of a negative number, but it outputs an imaginary number, not a real number. So those are the two things we want to avoid happening, okay? And even more so, it doesn't have to be a square root. Taking an even root, any even root, such as 4th root, 6th root, 8th root of a negative number outputs an imaginary number. Odd roots are fine, cube roots, 5th roots, 7th roots, etc. So these are the two calculations that we need to avoid, okay? So I'm going to give you a couple recommendations here. The first one is focus on denominators, since we can't divide by zero, and even roots, typically square roots. But you would treat a 4th root just like a square root when you're looking for a domain. Secondly, this is a big one. A lot of people try to skip this part, but I think it's really important. Visualize the domain on a number line before trying to write the interval notation, okay? Because if you can see your domain, then the interval notation part, which is typically how you write domain, the interval notation part's easy if you've got a picture of it on a number line first. Alright, so let's get down to some examples. Write the domain in interval notation. Okay, so the first example we'll do is f of x equals 2x squared minus the absolute value of x plus 3. And when you look at this, we're looking for x values, inputs. If I input a number into either of those x or both of those x's, will this entire output, this entire calculation, will it give me a real number? Well, of course it will. If you take the absolute value of a number, you get a number. And if you square a number, you get a number. And you can subtract and all that, and it's just fine. The point is here, no matter what we put in here for x, we're going to get a number out, a real number, in fact. And that's because, notice we don't have any denominators, in other words, no fractions, or even roots. So our domain is every single number, okay? So if I were to look at a picture of that on the number line, it would look like this. I would shade the whole number line. Every number on the number line is an appropriate input, an appropriate x value. So my domain is this one interval. So the interval notation for my domain Well, my left endpoint is negative infinity of what's shaded, and my right endpoint of what's shaded is positive infinity, and I can never shade the infinities, so I put parentheses around those. So that's my domain for this function. And so oftentimes, most functions, I would say, have a domain of all real numbers like this, because most functions don't have denominators or even roots. That's only 2 calculations out of the many that there are. So kind of watch for that. Sometimes this gets forgotten. Here's another example, the cube root of something plus 4. And again, you can take a cube root of any number. So no matter what you put in here for x, it's not going to cause any calculation problems. And adding 4, of course, is not going to cause any calculation problems. There's no denominators, no even roots. So the domain is all real numbers again. And of course, we just saw the number line picture of that. It's negative infinity to infinity is the domain of this function. Let's try another one. H of x equals x minus 3 over x minus 9. And so now we do have a denominator, so we're focusing our attention there. In fact, for this x on top, why am I looking at x? Domain is the input, so what I'm looking at is what numbers can I plug in for x's that won't cause me a calculation issue. This x on top, I can plug anything into that guy, because I don't care what my numerator is in a fraction. But my denominator is where I have an issue. So I'm trying to figure out, are there any values that I don't want to plug in for this x? Okay, so if I were to look at my number line, I do not want my denominator to be 0. So my domain number line, or my x number line, this is like the x-axis by the way, I would not want x to be 9, so I'll mark 9. Because if x were 9, that means my output would be dividing by 0. So I'll write that above there. So I do not want 9 to be shaded on my number line, because I only want to shade the numbers that are in my domain. So I'm going to sort of put a barricade around 9, this open circle around 9, to make sure I don't shade it. Now, can x be other numbers? So can x be 5? Well, 5 minus 9 is negative 4. So 5 over here should be shaded. Okay? In our final answer. Can x be 1,000? 1,000's way up here. 1,000 minus 9 is 991. I can divide by 991, so that number should be shaded. In fact, what about numbers really close to 9, like 8.9? 8.9 minus 9 is not 0. That's all we care about. That's the only number I can't divide by. So every other number besides 9 is in my domain. So I'm going to shade every number to the left of 9, and I'm going to shade every number to the right of 9. And now my interval notation will be 2 intervals. This interval, union, this interval. So the yellow interval, the left interval, is negative infinity to 9, not including either one because this 9 is not shaded, union my right interval starting at 9 and going on to positive infinity. So this is my domain in interval notation, every number except for 9. Let's look at another one. So again, I have a denominator. I don't want that to be 0. So this is what's called quadratic. I need to figure out what makes this thing equal 0. So in other words, I need to solve the equation where that thing equals 0. So in the previous example, I could figure out that x minus 9 is 0 by looking at it and saying, oh, x could be 9. Or I could solve this equation, x minus 9 equals 0. And I could figure out if I add 9 to both sides, that would give me an x value of 9. And so that would tell me where to cut my number line here. Okay? So the same thing happens down here. I need to know where this thing equals 0. So set it equal to 0 and solve this equation. Now this is a quadratic equation. This thing's a quadratic equation. And you can solve that many different ways. One is by factoring. So if you do it by factoring, I'm not going to teach you how to factor in this video. You can go figure out how to factor a trinomial using one of my videos or someone else's videos. It factors as x plus 1 times x plus 4 equals 0. And then I have to figure out what makes each of these equal 0. So x plus 1 is 0, or x plus 4 is 0. So x is negative 1, or x is negative 4. So those are the two x values that make this 0. Or you could use the quadratic formula. And again, I'm not going to teach you how to use it here, but if you do the quadratic formula, you'll also get x equals negative 1 or x equals negative 4. So those are the two x values that make the denominator 0. So if I look at my number line, I'm going to mark negative 1 and negative 4. Now negative 4 is to the left of negative 1. And x cannot be either one of those. So I'll mark this as my x number line, my domain number line. X can't be negative 4, because if it is, my denominator would be 0. And x can't be negative 1, because my denominator would be 0. But x can be any other number. So I shade all the regions around. So I've got negative infinity to negative 4. That's my first interval. Union, negative 4 to negative 1. Union, negative 1 to infinity. So this one looks complex, but it's really not that bad. But you do have to know how to factor or use the quadratic formula to figure out the solutions to the quadratic equation. Okay, so here I have an even root. So I need to look at this x and see if there's anything I can't plug in there. So if I look at my x number line, my domain number line, some numbers I can't plug in there are like 7, because 6 minus 7 is a negative, and I cannot take a square root of a negative. So I cannot shade 7. I can't shade 8. I can't shade 9. If I plug in any of these big numbers, then I'm going to get a square root of a negative. So I don't want to shade those. So let's look at the other side. What about like negative 10? 6 minus negative 10 equals 6 plus 10, which is 16. I can take the square root of 16. So negative 10 will be shaded on my number line in the final answer. And by the way, I'm just looking at specific numbers here to get a feel for what can x be. Can x be negative 2? Well, 6 minus negative 2 is 6 plus 2, which is 8. That's also positive. I can take a square root of a positive. What about 0? 6 minus 0 is positive. What about 5.9? 6 minus 5.9 is positive. What about 6.1? 6.1, well, 6 minus 6.1 is negative, so I can't do that. So you can see the left side of my number line, those numbers seem to be shaded, and the right side does not. So let's look at this in a little less cluttered way. At what point do I stop shading stop shading and leave these numbers out? Well, that goes all the way up to 6, right? Because 6 minus 6 is 0. So if I plug in numbers smaller than 6, I'll get a positive number, and if I plug in numbers bigger than 6, I'll get a negative number under the square root. So that tells me I'm going to shade every number to the left of 6, all the way up to 5.999999, but not 6. Well, let's talk about 6. If I plug in 6 for x, 6 minus 6 is 0, and I can take the square root of 0. Everybody forgets that. That means 6 will be included in my domain. It's going to be shaded. But as soon as I surpass 6 and look at 6.01, 6 minus 6.01 is negative. And in fact, any number over here for x will make a negative under the square root. So none of those numbers are on my domain. So my domain is negative infinity up to 6, including 6, so I use a bracket. So that's my interval notation for this domain. Last example. I'm going to go kind of fast here because I'm running out of time on my video. I can see that I've got a denominator and I have an even root. So I'm going to have two things to combat. I'm going to look at my denominator first. What's going to make that equal 0? Well, if x is 0, then 0 cubed is 0. So x can't be 0. So I'll mark 0 on my number line, and I'll put an open circle around it to make sure I don't shade. Now I'm going to look at my numerator. Usually I'm not concerned about a numerator, but this is an even root. Numbers, let's see. If I plug in numbers to the left of negative 7, I get a negative under there, so those won't work. So I need to shade the numbers to the right, except for 0. So my domain is all the numbers -7 and higher except for 0. The numbers here are left out because I get a fourth root of a negative, and this number is left out because I'd be dividing by 0. But every other number does not cause any calculation issues whatsoever.